Hi guys, and welcome to Module 3. On Module 3 we talked about rational numbers. Now rational comes from the word ratio, which means you take a number and you can divide it by another number. A rational number is a number that can be written as the ratio of two integers. And basically what that means is I can take a number as my numerator and divide it by my denominator. So for example, whole number 2 is a rational number because I can divide 2 by 1 and end up with whole number 2. Integer -3 is also a rational number because I can end up with -3 by dividing numerator -3 by denominator 1. -1/2 is also a rational number because I can get -1.5 by dividing -1 as my numerator and 2 as my denominator. And lastly, 25/100ths as a decimal is also a rational number because I can end up with that by dividing numerator 1 divided by 4. A rational number is a number that can be written as a numerator divided by a denominator, where the numerator and the denominator are integers and your denominator could never be 0. You can't divide by 0. So if we look at this graph, let's talk about what this looks like. This Venn diagram is showing us that whole numbers include 0 and they're just my positive numbers. Integers, as you know, includes both your positive and your negative numbers, including 0, so they include your whole numbers. And then lastly, rational numbers are everything. Those include whole numbers, integers, and fractions, and decimals. So like we discussed in class, whole numbers are just your positive numbers, including 0. Integers are now your positive numbers including 0 plus your negative numbers. And then rational numbers include everything. 0, positive numbers, negative numbers, your decimals, and your fractions. Now we talked about because a rational number is dividing a number by another number, we end up with either a terminating decimal. The word terminating means to end, and so when we have a terminating decimal, that decimal is going to end. So some examples would be 1 5/10, it ends there, -25/100ths, it ends there, or 10 625,000ths. Now, contrastly, a repeating decimal is a decimal that has a pattern that repeats. So, for example, 1 and 3, if you divide that in the calculator, you're going to see the 3 repeating itself. So you definitely don't want to sit there and continue dividing until, and you continue seeing 3. And so you would put that bar notation at the top of the number that's repeating itself. So again, just to recap, a terminating decimal will end, whereas a repeating decimal has a pattern that repeats. Now let's take a look at this slide where we are representing division as a fraction. We have an example here where Alicia and her friends Brittany, Kenji, and Ellis are taking a pottery class. So there are 4 of them, 4 friends, and they have to share 3 blocks of clay. The question is asking how much clay will each of them receive if they divide the 3 blocks evenly. Now, a couple things going on here. First, we want to make sure that we can identify key information. What's important is that there are 4 friends. Also important is that they have to share 3 blocks of clay. And lastly, we want to be able to determine how we solve this problem. So the question is asking how much clay will each of the friends receive if they divide the 3 blocks evenly. Now, if we were in elementary school, we'd take a look at this and go, this is impossible. There's no way that we can divide this. Now, being in 6th grade, we've learned that we can divide 3 blocks of clay amongst 4 people. We have a visual with the 3 blocks of clay, and we also have a fraction that represents this problem. We have 3 blocks of clay, that's your numerator, and divided by 4 friends, that's your denominator. So you're dividing by 4. We also talked about in class how we remember who goes on the inside and what number goes on the outside. So we talked about how the numerator, starting with the letter N, he naps inside. So he's the one that goes on the inside. And the denominator, he's the dog, he goes outside. And so let's go ahead and take a look at how we would divide 3 divided by 4. Now, we know that 4 does not go into 3. So we know that 4 goes into 3 0 times. But we do know that we can split this and everybody will get a piece. So we're going to go ahead and put this decimal point. This decimal point is going to represent the piece or the fraction that each one is getting. And then we're going to go ahead and add a 0 here. So we know that 4 goes into 30 7 times because 4 times 7 is 28. And we take 28 from 30 and we know that that's going to give us 2. And we continue adding zeros until we get either a terminating decimal or a repeating decimal. So 4 now goes into 20 5 times, and so 4 times 5 is 20. It went into it evenly, and we ended up with a terminating decimal of 75 hundredths. So each person would then go ahead and get 75 hundredths or 3/4 of each piece. Okay, let's go ahead and try another. We have 1 divided by 4, so we know that the numerator goes on the inside and the denominator goes on the outside. And so we have 1 divided by 4. Well, we take a look at this and we go, well, 4 will not go into 1, so that's a 0. And we know that we're going to put our decimal point because it's going to be pieces now. And we start adding zeros until we reach either a terminating or a repeating decimal. 4 goes into 10 2 times. 4 times 2 is 8. We take 8 from 10, and that gives us 2. And we continue adding zeros. 4 goes into 25 whole times. And so we see that this is going to give us a terminating decimal of 25 hundredths, which makes a lot of sense to me because I know that 1/4 or 1/4 is equal to 25 hundredths or 25 cents. Now, we also talked about how we would write rational numbers as a numerator divided by a denominator. So if I have a mixed number like 3 2/5 and we needed to turn that into a rational number, that means simply that we just have to determine who the numerator is going to be and who the denominator is going to be. And in class, we talked about how we can figure this out by doing the circle dance. So the circle dance tells us that I'm going to go ahead and take my denominator, multiply it by the whole number. So 5 times 3 is 15. And then I'm going to go ahead and take that 15 and add 2. And so my numerator is going to be 17. My denominator stays the same. And so the mixed number converted to rational number as a fraction would be 17 as my numerator and 5 as my denominator. We also discussed how we turn a decimal into a rational number, and we also talked about how the decimal simply shows 6 in the tenths place. There is nothing in my whole number place. There is a 6 in the tenths, so that simply means the 6 is divided by 10, or 6 as my numerator and 10 as my denominator. Now, what happens when we have to write a whole number as a fraction, as a rational number? Well, if I have a whole number 34, what is it that I divide that by to end up with whole number 34? Well, that's simple. You take the number as the numerator, 34, divided by 1, and that is the fraction that will represent the whole number. Similarly, if we have a negative number, a negative integer of -7, and we wanted to write that as a rational number, we would do that by simply representing the -7 divided by 1, or -7 as the numerator and 1 as the denominator. We also talked about in class, now that we know about rational numbers, how we would go ahead and apply this. If we needed to order 2/10, 3/4, 8/10, half, and a fourth, and 4/10 from least to greatest, what we would have to do is we have a combination here of decimals and fractions. So we're going to go ahead and change the fractions to represent decimals. So the 2/10 is already as a decimal. We're going to take the 3/4 and we're going to turn that into a decimal. Now, 3/4 is one of those common fractions that we discussed in class that we should know. We should think about quarters. 1/4 is 25 cents. 2/4 is 50 cents. 3/4 or 3/4 is 75 cents. And 4/4, of course, would be your whole dollar. You also can determine what the decimal for 3/4 would be by simply dividing. 3 is your numerator and 4 is your denominator, as we saw in the previous slides. 8/10 is already as a decimal. 1/2 is equivalent to 50 hundredths or 5/10, which is the same as we discussed a common fraction that we should know. And there's that other one, 1/4, which is 25 hundredths. If we wanted to order these on a number line from least to greatest, the easiest way to do this would be to plot them first. So you would plot the 2/10 as seen here. You would plot the 25 hundredths. Well, the 25 hundredths is going to fall somewhere in between your 2/10 and your 3/10. Like, think about it like money. If you have 2/10, that means you have 2 dimes. That's 20 cents. 3/10 would be your 30 cents. And so 25 hundredths would be right there in between. And there it is. You also have to plot your 4/10, your 5/10, your 75 hundredths again would fall between your 7/10 and your 8/10, and lastly your 8/10. So once we plot these, it makes the question a lot easier, because all we would have to do is then determine which one is least to greatest. Well, we understand that in a number line, our numbers are going from least to greatest. So we would go ahead and say 2/10 is less than 25 hundredths, is less than 4/10, is less than 5/10, is less than 75 hundredths, and lastly, less than 8/10. Okay, let's go ahead and practice one together. So we're going to order the fractions and decimals from least to greatest. Again, combination of decimals and fractions. So we're going to go ahead and turn those fractions into decimals so it's easier to plot on the number line. 85 hundredths, already a decimal. 3/5 is one of those common fractions that I told you about. If we think about the denominator 5, and I told you guys to think about your $20 bills. If you think about 20, 1/5 is 20, 2/5 is 40, 3/5 is 60, 4/5 is 80, 5/5 is your 100. We also can divide 3 divided by 5, like we saw in previous slides, to see that that will be equivalent to 60 hundredths. So we're going to go ahead and identify this one as 60 hundredths. We already have the 15 hundredths as a decimal, and then 7/10 is easy. That one is just 7/10, and we can add a 0 there because we understand that adding zeros to a decimal does not change its value. It's the same as saying either I have 7 dimes, which is 70 cents, or 70 pennies, which is 70 hundredths. Again, 70 cents. So we're going to go ahead and create a number line. We're going to plot these. We don't have any negative numbers, so we're just going to pretend everything is positive here. And I'm going to say that 85 hundredths is going to be somewhere all the way over here because he's really close to a full dollar. And then 3/5, we identified it as being 60 hundredths, so he isn't quite over by the 85 hundredths. He's over here somewhere, 60 hundredths. And then we have 15 hundredths, and we know that he's somewhere over here on the left because he's less than. And then lastly, we have 7/10, which we know is the same as 70 hundredths. So he's going to go between 60 hundredths and 85 hundredths. If we needed to order these from least to greatest, see how easy it is now that we have just plotted them on the number line. Because now we can simply, knowing that the number line goes from least to greatest, determine that 15 hundredths is less than 60 hundredths, who's less than 70 hundredths, who's less than 85 hundredths. Now let's apply this in a real world scenario. If we have 5 friends and they completed a triathlon, it included a 3-mile run, 12-mile bike ride, and a half-mile swim. To compare their running times, they created a table that shows the difference between each person's time and the average time, with negative numbers representing times less than the average. So those were your faster people. The average time would be like your 0, and then the people on the negative side would be the ones that got there faster because they made it in less time than the average time, and then the people on the positive side would be the ones that took a little longer than your average time. So my first recommendation every single time we see a table or a graph is always to interpret it, become familiar with it, and understand it before you answer absolutely any question from it. So we have John. These are the runners. We have John, Sue, Anna, Mike, and Tom. And then the time above or below average minutes, we have John at half a minute above. We have Sue at 1 4/10 minutes above. We have Anna at -1 1/4, so she was fast. And then we have Mike, who was at -2, so he was really fast. And Tom seemed to be at 1 95 hundredths. So the first thing that we have to do is turn these fractions into decimals. So let's take a look at John. Let's do John first, and I see that John is 50 hundredths, 1/2, and then Sue is 1 4/10, so she's already as a decimal. We're going to take Anna and we're going to convert this -1 1/4 into a decimal. Well, we understand this is a negative number, and 1/4 represents 25 hundredths. So she's at 1 25 hundredths. We have Mike at -2. He's already as a decimal, and Tom already at a decimal at 1 95 hundredths. So let's go ahead and let's create our number line here. We do have a combination of positive and negative numbers, so we're going to put 0 as the middle guy there. We're going to put John to represent the half, and John is going to be over on the positive side. He's at positive 1/2. We have Sue at 1 4/10, so she's beyond 1 minute. She's at 1 4/10 of another minute. Anna is at the negative side, so we're going to go ahead on the left-hand side, and we're going to identify her at -1 25 hundredths. We have Mike at -2, and so he's over here somewhere, because remember when we talked about negative numbers, we are going further to the left. And then Tom is at 1 95 hundredths, so he's going to be on the positive side, and he was pretty much the slowest guy there. So if we looked at this, they're asking us to order these to compare their running times. They created a table. Let's see. And so we're going to go ahead and compare these runners. We see that -2 is less than -1 25 hundredths, who's less than 0. That's less than 1 1/2. That's less than 1 4/10. That's less than 1 95 hundredths. So talking about this being a race, we would clearly see that Mike was the faster one because he's the one that did it in less time. Anna was pretty quick, but not as quick. And then we have, after the average time, John. And then we have Sue, who was a little slower, and then the slowest one in this race was going to be Tom at +1 95 hundredths past the average time. I hope you enjoyed Module 3, where we discussed rational numbers. We will meet again next time for Module 4.